sucks.
Yeah.
Okay. So we're going to continue to talk about the pathogen. Now, I put on the eCampus is some of the after-class reading material. So you can go ahead to read it. Now, again, you don't have to remember because it's an open book. But you at least are going to go through these. For example, you can look around, you know, what is called the Lancefield groups, what is called alpha hemolytic streptococcal, what is called beta hemolytic strep. And all these things here, let's say get a very good conclusion right here. Then you have a case study. We're going to go over these sometime when we finish this section. And Staphylococcus case study, we're going to go over these, okay? So we have a 3 set of these after class reading, and you can go ahead to read it. For example, this is talk about corynebacterial diphtheria. We have a case study related to that. Like I said, the exam will have some case study. Now, of course, it's open book, but it's good you get familiar with these, so you go ahead to read it. And why it is important? Because at a general education class, this is the most common disease happened in the United States. And you heard about these Streptococcus pneumoniae, Haemophilus influenza, a DTaP vaccine, you know, let's say Clostridium, we're going to go over these. This is all the fact sheets for Clostridium, okay? So these 3, you definitely read it and bring it to the exam too, and it's useful for answering the questions. So let's finish talk about what we left here. So we talk about all these pathogens. Then we talk about Streptococcus, so we haven't talked about the Staphylococcus yet. So we want to start from here. So right, go down. Yes, Staphylococcus. So let's talk about these things first. We have Streptococcus, and we have Staphylococcus. So let's say this is a mixed culture. We can do gram stain. We do a gram stain. What we find? Both of these are gram positive. And this is also a gram positive. And both of these are coccell. Okay, both of these are coccell. And what's the difference? Streptococcus is chain. Most likely, like this. And Staphylococcus is grape shape. Or we say grape cluster. So it looks like a grape. Like that. But I want to tell you one thing. In the real life, underneath microscope, when you see those, it is difficult to differentiate. So this is theoretically we say, oh, strep is chain, Staphylococcus is grape shape, but it's hard to differentiate in the real life. So the reason is grape could be, you only have 3 grapes, is that right? When you eat, you left those 3. That could be looks like that, the Staphylococcus. So what they do, we have a very easy test called a catalase test. So what's a catalase test? We had hydrogen peroxide put on the glass slides, and if bacteria have catalase, what they're going to find will generate water and oxygen. And this oxygen showing on glass slides is bubbling. So it's very interesting. It's bubbling. You add a drop of H2O2 on the colonies, or on the glass slides with the colony, it's going to bubble. Then it's positive. So we do this test, we find Streptococcus is catalase test negative and Staphylococcus is positive, which means it's bubbling. But keep in mind, it's very important that this catalase test you cannot do on the blood agar, because blood agar already have oxygen there, so you'll get false positive. It's very interesting. Lots of people think, oh, I have a blood agar. Blood agar have alpha hemolytic, beta hemolytic. How about let's just do catalase test? Let's just put a couple of drops of H2O2. Well, unfortunately, we'll give you false positive. So that's Staphylococcus. Now, Staphylococcus, we want to go a little bit easy. So we will talk about basically three things. The first one called Staphylococcus epidermis. And I usually say this is the one is normal bacteria on surface. So this is a normal bacteria, unless it's translocated. It's a normal bacteria on the skin surface called Staphylococcus epidermis. The second one, Staphylococcus saprophyticus. So what's that? This is a pathogen target 25-year-old woman, 20 to 25-year-old woman, sexual activity, active person. So it's a sexual transmitted disease. And we gave them a nickname called honeymoon bacteria. So sexual activity, active girl, have sexual action, and will showing you up is abdominal pain with urinary tract infection. And this pathogen is very easy to test, because when you go to see a doctor, you just test a little bit of antibiotics called novobalsine. This pathogen is resistant to novobalsine. But Staphylococcus epidermis is susceptible. So in the hospital, let's say a mom taking a 25-year-old daughter to see a hospital, and the daughter says she had a urinary tract infection, which means difficult to pee, we call it dysuria, and then the doctor gets some of the urine samples and to do a quick test, and they find it's resistant to novobalsine. And then he will ask the mom. The mom think about there's a couple of nights the girl didn't go back to home, so that's match the case, which is Staphylococcus saprophyticus. Because using novobalsine quick test is very easy to diagnose. Okay, so that's Staphylococcus saprophyticus. Then we go to Staphylococcus aureus. And this is the one we want to spending a little bit of time to talk about that. We basically talk about is three things with Staphylococcus aureus. Number one, this is a food intoxication pathogen, especially for chicken salads. So what happened is people preparing chicken salads, have a chicken, have salads, and messed it up. In the cold weather like today, they were sneezing like that. Oh, then they have the bacteria from their nasopharyngeal come from everywhere. They touch it. Okay, then they get contaminated, especially with the people who doesn't wear gloves in the fast food restaurant or any places. The chicken salads is very cheap. It's like $3, $5 sometimes with coupon. And then they just pack it and you eat it. What happened? Just like 3 to 6 hours onset time, you have a diarrhea, vomiting, and nausea. That's a chicken salads, which is food intoxication. Well, we only say it's a mild symptoms, but this is still a foodborne pathogen, we can say. But the difference is that we don't have to report to CDC. It's still counted as a mild symptoms because the death rate is zero. You're not going to cause death. So that's one of the things called chicken salads, food intoxication. Second one, we talk about the Staphylococcus aureus. We need to talk about this very horrible stuff, which is T. SST1. Toxic shock toxin 1 will cause toxic shock. So this is what happened is in 1970, a company called Riley, they created a very highly absorbent tampons for women to use in the period of time. Then what happened? This product is highly absorbent. So the water and the moisture in the vagina tract is completely absorbed. Then what happened? Because the moisture amount is lower, it's going to kill the normal bacteria. Let's say lactic acid bacteria. Or some of the normal bacteria in the vagina tract, which is a protection line, they are gone, and the Staphylococcus aureus is going to dominate. Once it's dominant, what happened? They started from the vagina tract all the way go up. Where could we go these bloodstream? And when they go to the bloodstream, they could release toxic shock factors or toxic shock toxin. And what happened is they will cause you lower blood pressure. Once you have a lower blood pressure, let's say this is the liver, so you don't have enough blood go to the liver, go to the kidney. Then what happens? These will start to decay or degrade, and then you have a shock symptoms. People could get killed. That's what happened in 1970s. The Riley tampons caused severe damage. I think it's caused about deaths of like 13 girls in the southern states. So this product is no longer in the market anymore. So with this toxic shock syndrome, you should remember this very well. Is Staphylococcus aureus in the history caused big damage in the public health because of this highly absorbed tampon. So that's the second one. Third one, everybody heard about it. You may heard about it. MRSA. What is that? Methicillin resistant Staphylococcus aureus. So what's that? So we will talk about antibiotics next week. Methicillin is the advanced production of penicillin. Originally, it tried to solve the problem is antibiotic resistant. But we are using it too much, so become a methicillin resistant Staphylococcus aureus. This is widely happened in 1980s in the hospital. So we call it a nosocomial infection, which means it is hospital acquired infection. The only reason is carelessness. People didn't do a good job of cleaning, hygiene, and sanitation on a daily basis. So, this is the key thing for the MRSA, methicillin resistant Staphylococcus aureus. Okay? So we will very briefly go over these Staphylococcus. Now, I want to mention several things about the Staphylococcus. Remember, we talked about the media, bacterial media. So how are we going to differentiate that? They are a very special media, similar to what we talk about the McConkie agar, can be used for differentiate Staphylococcus is mannitol salt agar. This is a very interesting media. Mannitol salt agar, same as McConkey agar, it is a selective media and it is also a differentiated media. Why we say it's a selective media? Because of salt. So you know salt will cause osmotic unbalance of a bacterial cell, wall cell membrane system. They will shrink, lose water. So salt is an inhibitor. All the food products, you see there is a salt there. Some of them are really salty, like hot dogs, hams. Although it's tasty, but salt itself is a very old first generation antimicrobials. It can kill bacteria. And we know some bacteria resistant to salt, so we call it halophiles. So salt is a selective agent. Another one is a mannitol. Mannitol is a differentiated agent because it's a sugar. It's a sugar alcohol. So what happened is, if mannitol fermentation positive, it is yellow color. If mannitol fermentation negative, it is colorless. Now, how do we know it is yellow? The reason in the mannitol salt agar, we have phenol red. This is a pH indicator. At a lower pH, it showed up yellow color. So in other words, this is a media. If you see a yellow colony, mannitol fermentation positive. So what happened here is Staphylococcus aureus is yellow color. Staphylococcus saprophyticus is colorless. And the Staphylococcus epidermis is also colorless. So that's one of the way we can differentiate that. Now we can also differentiate that. We mentioned novobalsin. Only Staphylococcus saprophyticus is novobalsin resistant. Others are susceptible. Okay, then we can do another one. When you look at the slides, I don't know whether you can see it here somewhere. Okay. We may not include it here. This is muscle, by the way. Staphylococcus aureus has a lot of the toxications. They could break down the whole system. It's a very invasive pathogen. One of that has an enzyme called coagulase. What is called coagulase? They could cause clumping of blood cell. So what happened is, if we have a blood saline on these tubes, and we add coagulase, let's say this is Staphylococcus aureus, this is Staphylococcus saprophyticus, and this is Staphylococcus epidermis. And you will see this is completely glued, which means this tube, you flip it over, it will not fall off. The liquid is all there because it's glued completely. This is another reason because of coagulase will cause low blood pressure in the blood vessel and in the bloodstream. Okay, so these are something I want to mention. It's very interesting, very typical for the Staphylococcus. Okay, so Streptococcus, Staphylococcus, we finished talking about here. Then we're gonna go to the slides right here. Is talk about other bacteria cause the disease. So we're gonna go a couple of the slides, and we're gonna go the details. So we mentioned about upper respiratory tract. Then we move on to human digestive tract. So you can see you have a salivary glands, oral cavity, esophagus, liver, stomach, pancreas, large intestinal, small intestinal, appendix, rectums, anus, all these. So first of all, how was the bacteria number in our alimentary tract? Stomach, very low bacterial number. Why? Because of stomach acid. Stomach pH is only 1 to 2. So they kill millions of bacteria. So basically acid resistant bacteria there. How about small intestinal? Well, a little bit large, 10 to the power of 4 cells. It's about 10,000 cells there. But did you notice it in the large intestinal? It's a high amount of the microbials. So if you get a fecal sample, animal or human fecal sample, you do the calculation and you do the sampling, you will find the bacterial number is huge. It's more than approximately 10 to the power of 12 cells per gram. And the majority of that are anaerobic bacteria. And if you take out the fecal sample, you have 1/3 of that are bacterial cells. This is one of the topic. It's very interesting. It's called guts microorganism. That is what's topic right now. People think your center of your body, all time we think it's a heart, then we think it's a brain system, but later on people think about your normal background flora in your intestinal and including small, large intestinal area. In other words, in the alimentary tract is the center. So that's lots of the research done that, including using 16S RNA technology, could do analysis, have like DNA fingerprints, all those things. So this is a topic. What you can do is in your end of semester's presentation. We're gonna get to that soon, okay? That's a topic you can find lots of the paper and the review article talk about the intestinal microorganism as a center of our body. So that's something you need to know. Normal flora of alimentary tract. Okay, this is some other concepts we want to emphasize it. We listed some pathogens and some of the disease. What we are talking about here? We are talking about here is a very easy and simple concept. The concept is called food infection compared to food intoxication. Infection versus food intoxication. So what is food infection? You are eating bacteria. Let's say E. coli, O157H7. Let's say Listeria. And let's say Salmonella. You're eating a bacteria, you get trouble. So what is the way to prevent or to combat the food infection? Is heating. So basically you heat it. It will solve the problem. That is called a food infection. Now what is food intoxication? You're eating toxin. This gives you trouble. Because even if you eat or cook it or heat it, it may not kill the toxin. The toxin is lots of the time is heat resistant. And a good example, Staphylococcus aureus. And also you will see lots of the Clostridium. So Staphylococcus aureus, nausea, vomiting, diarrhea. We have a Clostridium botulinum, double vision, swallowing, breath problem, Bacillus cereus, vomiting, abdomen pain, diarrhea, nausea. All these things will happen is an example of food intoxication because you're eating the toxin. And the onset time is very short. It is about could be less than 6 hours. Okay. Next, we want to introduce you a major foodborne pathogen, which is class level 3, biosafety level 3, Clostridium. Do I just write Clostridium SPP? Okay, Clostridium is really special. This is a gram-positive, large-shaped, endosspore-forming bacteria. It is very strict, anaerobic. What this means? There is no SOD, there is no catalase. Oxygen is a toxin, strictly anaerobic bacteria, and endosspore forming. So Clostridium is a big risk in the old time. Now we want to go over all these, okay? First of all, Clostridium botulism, or Clostridium botulinum. We want to mention 3 things. Number 1, we would love to talk about wound botulism. This is relatively simple. Okay, you have a cut on the arm. If you work in the machine shop or factory, you have a cut on the arm. The cut is by a scissor, by a metal detector, or any kinds of tools. There is a decay there. It could be contaminated with Clostridium botulinum or other Clostridium species, because the cuts area that along microenvironment is anaerobic. So that's wound botulism with cuts or abrasions or bites sometimes. Second thing is infant botulism. What is infant botulism? We say a joke is never feed less than 1-year-old baby honey, because otherwise you have floppy baby. Looks like that. That's a floppy baby. So what happened? Little bit anatomy and chemistry. The muscle can do contraction and relaxing. Is that right? Muscle contraction, we need a chemical, is called acetylcholine. And muscle relaxing, we need chloride. And these toxins, they are blocked what? Chloride. So, they are blocked acetylcholine. So they cannot do contraction, they're always relaxing, then become a floppy baby. Because the honey is a good resource for Clostridium. The normal human beings, the adults, will have the problem. All have the problem because you have a normal bacteria in your intestine. The less than 1-year-old young babies, the infant, they don't have established intestinal and the guts areas of normal bacteria. They don't have that defense system. So very easy will have problem. That's infant botulism. What else we have is food botulism. This is related to a very special food. Look at the top, the canned food. foods, we also call it low acid foods. It is very interesting products. Is water activity more than 0.85, pH around 4.6. Because this environment will kill lots of the normal bacteria, and then the Clostridium botulinum will dominate. So what they do, there are several things what you can do. In the canned food, you could add some ingredients to decrease the pH. So for example, at West Virginia, the regulation set up by the Department of Agriculture is pH less than 4.0. Then what you do? You're gonna add some ingredients there, let's say citric acid, for example. Sometimes vinegar or citric acid concentrate. The idea is let the pH go down, but it may not be enough. So what we do pressure cooker. Pressure cooker, the pressure needs to be more than 15 psi, and temperature have to be at least around 121 degrees Celsius, and heated at least 15 minutes. The idea is to kill endospore. That's what a pressure cooker looks like. Now, when you get to botulism, what you have to do? It's a toxin. So you need to using toxin. That's called antitoxin. So you need to using antitoxin immediately before you add antibiotics. Antitoxin in the United States, most of the time they ship from the airport. In the southern, they ship in directly from Atlanta airport. And they are made by equine blood stream or blood cell. So it's an anti-equine toxin. So you call the CDC will calling Atlanta airport to shipping anti-equine toxin immediately. This has to report it to CDC. Now what's the symptoms? We already talked about neurological symptoms. Double vision, difficult to speak, difficult to swallowing, all those things. So that's kind of a very interesting pathogen, Clostridium botulism. But more important from the safety standpoint, it's related to the canned foods. That's Clostridium botulism. Next one, Clostridium tetanus. Okay. Clostridium tetanus, I'll go a little bit easy. First of all, this pathogen should not be a problem in the United States. Why? We had a vaccine, BTAP. What are these stands for? We talk about Clostridium, Corynebacterium diphtheria. Bordetella pertussis causes whooping cough. A, that means acellular. This doesn't mean anything. Cellular. What is T? Clostridium tetanus. Okay, Clostridium tetanus, what they come? In the normal life, very similar to Clostridium botulism, the wound botulism. The wound tetanus is more easily to happen. If you touch a decayed or metal tools, get a cuts. And assuming you don't have a vaccine, it will be penetrated into your bloodstream, cause a problem. What's the problem? Lockjaw. The very simple lockjaw, which means completely muscle contraction without any relaxing. So what this tells us? It's prevent the toxin prevent, the chemical regulates the muscle relaxing. So what is that? That's chloride. So in here you can understand tetanus caused lockjaw. And botulism caused floppy baby. So they are pairs, but they are working opposite direction. One is working to prevent a muscle contraction, another one is prevent a muscle relaxing. But tetanus shouldn't be a problem because we have a vaccine. Now, tetanus has a problem. Yes, they may get from newborn baby, from the mom. If you do home delivery with unqualified, unsanitized facility, this is very normal happen in the Asian countries back in almost like 100 years ago. They do the delivery at home, not go to the hospital. And then with some of the midwife, only some of the experienced people, but they don't have a very good sanitation standard operation procedure. So very easy cause. Baby infant tetanus caused by those unsanitized tools used during the baby delivery. Okay, so this is something we want to mention. So look at here. Wound infection, muscle stiffness prevention, antibiotic therapy treated with antitoxin, and DTaP should be a vaccine is most effective between. So you may not know the chemistry very well. I have a slide here. This is what I talk about. Botulism and tetanus. So muscle contraction, there is a signal chemical, which is we call as a neurotransmitter, is acetylcholine. And the signals aim muscle to contract. Botulism blocks it, acetylcholine. So what happened? Muscle is relaxing. There is another chemical which is called glycine to signal relax. And then the tetanus toxin blocks the release of glycine. So that what happens becomes completely contracts. There's no relaxing. That's caused the problem. And this is floppy baby, and the other one is lockjaw. So this is a slide which tells you a very simple story behind the toxication effects of botulism and tetanus, using a very easy flowchart to show you. Okay, next one. Clostridium perfringens. So first of all, Clostridium perfringens has a very typical growth situation on blood agar. It is double beta hemolytic zone. So what happened is on the blood agar, if you streak Clostridium perfringens, you will see is a neck by neck attached transparent zone. That's beta hemolytic zone. Others doesn't have it. Clostridium perfringens cause a very typical symptom. Gas, gangrene. And what it looks like. That's what gas gangrene happened. Why will it looks like that? So assuming on the hands or on the muscle, you have a cuts. That gives you an environment which is almost from allophilic to strict anaerobic. Clostridium perfringens will dominate. This pathogen has an enzyme, can break down muscle tissue and generate a gas. Once the gas is there, what happens? It's a pressure. So they press the blood stream and will not enough blood go to the tissues and organs. So different from Staphylococcus toxin. Staphylococcus toxin is give you lower blood pressure, and this is give you extremely pressure to press blood stream to not let enough blood go to the target organs and the tissue. So cause the decay of this area. What we call is a necrotizing infection of skeletal muscle or Clostridium malnecrosis, cause necrosis. Now, Clostridium, where will it come from? It's usually from food products. It's not well prepared. So you always should remember, there is a dangerous temperature zone for food. It is 40 to 140 degrees Fahrenheit. It is 5 to 60 degrees Celsius. This is called dangerous temperature zone. Said very simple, keep cold food colder, heated food more higher temperature. Higher temperature. If you do cold storage, make sure it's below 4.5 degrees Celsius. If you're heating something, make sure it's more than 60 degrees Celsius. Because otherwise, the normal bacteria could be killed, and then the indoswell pathogens started to dominate. So that's you have to avoid. The prevention of this one is to avoid dangerous temperature zone. Okay, that's Clostridium perfringens. Clostridium difficile, the last one. This is the one is very interesting. We want to talk. Clostridium difficile. First of all, Clostridium difficile is same as we just mentioned the MRSA. It is a nosocomial infection. It is a hospital-acquired infection. And what type of the situation will happen is the person intensively using antibiotics for 7 days. It's completely kill normal bacteria and lets Clostridium difficile dominant. What will have the symptoms is Clostridium difficile caused colitis. Looks like that. Pseudomembrane colitis. Pseudomembrane colitis. You will see these spots are either red or swelling pus, which is dead blood cell has inflammation. If you're using colon spectrum system to do the testing. Okay, this has happened. It's like 70 years old grandma in the hospital, continually 7 days using amoxicillin. Will cause a problem. What's the symptoms? Bloody water diarrhea. Okay, how are you going to do the treatment? That's very interesting. The treatment I have 3 ways to do. Number 1, using another antibiotics. If during the 7 days you are using amoxicillin or penicillin, switch to normal vancomycin or vancomycin. The reason is target attacking points for vancomycin and penicillin are different. And we will talk next week when we talk about antibiotics. But this is very ironic. How come? You already said this patient is intensively using 7 days antibiotics. Oh, now you said we got to change to another antibiotics. You're still doing the same job. So very ironic. Switch to another antibiotics, vancomycin. Second one, you can drink lactic acid bacteria rich products. Let's say yogurts. What's the idea? Is to let your normal bacteria redeveloped. But if it's severe symptoms, what are you going to do? Fecal transplant. Nobody wants to do this. Nobody wants other people's poop in your body. But you have to do fecal transplant if it's severe. The idea is you don't have any normal bacteria. Basically, you lose the function of the intestine, including like contraction, also the physical activity. You need to put them back. So, you need to put a normal bacteria, the normal fecal contents from other person go to your body. Seems horrible. But that's what you have to do if it's a life-threatening situation. Now, another thing I want to mention, Clostridium difficile originally is a human pathogen, happened in the hospital. In the last 10-20 years, it started to transmit to food supply chain because of the food contaminated with the fecal sample, animal-human fecal sample. So once in a while, the Clostridium difficile related to the research has been done widely in the food microbiology area. The USDA has been supported several big grants to do that. But later on, it's not a hot topic anymore. But just want to let you know, in the history, this has been a big issue. Okay, now how we do the diagnosis? We can use a fluorescence microscope or using